Lots of people. Hello. All right, so you are here for the State of Sorbet, a type checker in Ruby. I am Paul Tarjan. I have been at Stripe about 3 years now on the developer productivity team. Before that, I was at Facebook working on HHVM and Hack, the PHP type checker. And I did my master's at Stanford.
And hi, I'm Jake. I've been at Stripe for about 2 years, most recently working on the Sorbet team. And before I came to Stripe, I was still in school working on studying programming languages at Carnegie Mellon.
All right, let's dive in. Today we're going to talk about 5 things. We're going to talk a little bit about Stripe. Then we're going to talk about our Sorbet adoption. We'll talk about our editor integrations. A bunch of really exciting announcements, hopefully. And then dive into some of the tooling stuff we've been working on recently. OK, Stripe. Hopefully you've heard of us. If you haven't, we are a platform to accept payments worldwide. I recently had to update this slide from last year, which was very exciting to see all the numbers go up over the year. We are in 32 countries now. Millions of businesses use us. We process billions of dollars annually. More than 80% of Americans used Stripe to buy something last year, or 2 years ago. That's where my stats are from. Very exciting. We're now up to 1,700 people, 10 offices worldwide. And my nearest and dearest to my heart, customers report 59% more developer productivity when switching to Stripe. So the proverbial stripe.com/jobs, they paid our flight over here. Please go to the URL. OK, what do? I am the technical lead for developer productivity. We are basically responsible from the moment you type git branch all the way until your code's in production. If anything in there is not going great, we are there to help you and there to fix it. So we do testing, obviously, the code abstractions, we do developer environments, we do code review, language tools, the documentation teams, a bunch of language platforms. The whole platform is what developer productivity does. We believe a lot in this, and hopefully you should too. But the Sorbet type checker is just a small part of our big mission of making Stripe engineers as productive as possible. What does Ruby look like at Stripe? OK, so we are, it's our primary programming language. All of our product code is written in Ruby. Yay. It is an enforced subset of Ruby. OK, so there's a lot of RuboCop rules. I very much love those. So thank you to the RuboCop folks. We have many hundreds. We are not using Rails as our abstraction. So that changes some of our type checking things. Most of our product code is in a monorepo. OK, so intentionally. This wasn't an accident. And we use macro services. There's about 10 services that are the primary ones that we focus on, and most code goes into those services instead of small microservice architecture. So that kind of paints a little bit of a picture for you about how the Ruby is used at Stripe. How big are we? I already told you some of our information about the hires at Stripe, but we are hundreds of engineers, thousands of commits per day, and millions of lines of code. Okay, so this is a big project. It's a substantial-sized Ruby code base to work with. OK, diving into a little bit about our type checker. So we are not doing this alone. We are very, very appreciative from all of the help that everyone else has been doing along the way. Jeff Foster, a professor at Tufts University now, previously Plum, wrote RDL for the last 10 years of his life. Him and a lot of students have been working on this. We're very appreciative from all of their work. We have used the standard library definitions that they have already written out for most of the standard library to bootstrap Sorbet. Charlie Somerville at GitHub wrote a wonderful port of the white quark parser into C++ so that we could use it in our Sorbet project. So we're very thankful for that previous work. And recently, Satoru has been working on Steep, and we've been collaborating with him, as well as Mame-san for his type profiler. We appreciate the collaboration there. And Mats, of course. We thank him for starting this whole thing. And recently, we've had 3 companies start to contribute code to Sorbet. So Shopify, Coinbase, and SourceGraph have all committed code back into Sorbet as they've been developing it and deploying it locally at their companies. All right, I'm going to hand it over to Jake to talk about adopting Sorbet at Stripe.
Awesome. Thank you, Paul. So I'm going to talk a little bit today about the process of adopting Sorbet at Stripe. So at a high level, it kind of breaks down into 3 main sections of time. The first 8 months of our project, we spent building Sorbet from scratch. So we started knowing nothing except that we wanted to type check Ruby, and we implemented a feature into the type checker, made sure that it worked, and moved on to the next one. And so after 8 months iterating like this, last year at RubyKaigi, we announced Sorbet for the first time. So the rest of this talk, we're going to chat a little bit about what we've been doing in the time since then. So the first thing that we did after we got home from RubyKaigi last year was we started to use Sorbet at Stripe. And we wanted to see just how much of our code base we could get to be typed. So how did we do this? Basically, we focused on identifying and then preventing certain classes of errors throughout our entire code base. So the first one that we see here is the first kind of error that we tried to tackle, uninitialized constant errors. If we take a look at this code snippet, we see that we've got a class called hello, and then it's got a main method that tries to instantiate hello, but it has a little bit of a typo. We're missing an L, and so if we run this with Ruby, it'll say uninitialized constant hello, did you mean something else? Which is a great error message. It tells us exactly what we needed to do to fix our code, and it's not too confusing. The only problem is that we actually had to run the code to get this feedback. And running the code might happen maybe 5 to 10 minutes from now when we run our test suite. It might happen later today when we deploy this code to production and look at our monitoring logs. But the worst case is we hear about it at 4 in the morning from our very upset user telling us that it's broken and demanding that we fix it. And that's not great. So we'd like to be able to get this feedback about this uninitialized constant as quickly as possible after having written the code. So with Sorbet, we just run Sorbet on our project, and in seconds it comes back and tells us unable to resolve constant and points directly to the line of code where we messed up. So after those 7 months at Stripe, trying to adopt Sorbet in as much code as we could, I'm happy to announce that we can actually catch this error in 100% of Ruby files at Stripe without having to run any Ruby code at all. So this is great. This means that we get super fast feedback, we get tons of confidence in our code, and we didn't have to make any changes to the code at all. So the next kind of class of error that we identified and wanted to fix in our code base was undefined method errors. We wanted to prevent them and catch them as quickly as we could. So we've taken this previous code snippet that we saw on the previous slide, and we've added a method to it called greeting that returns a string. In our main method, we now try to call this greeting method, but we've accidentally messed up the name. Instead of calling greeting, we're calling a method called greet. And so again, if we tried to run this code, Ruby would tell us there's an error. And again, it's a great error message. It tells us exactly what's wrong and on what line. But we had to actually run the code. We'd like to be able to use Sorbet to augment our confidence, to gain more than just tests alone would be able to give us. So by making one small change to this file, adding typed true in a comment at the top of the file, Sorbet can actually now catch this error. And if we run Sorbet, it'll tell us method greet does not exist. So we can prevent this error with Sorbet statically. And then the only question left is, this is a toy example, can we actually do it in a large project like Stripe's code base? And so after 7 months, with a team of 3 or 4 people trying to adopt Sorbet in all of Stripe, after those 7 months, we can we can catch this error in 80% of Ruby files at Stripe. All we had to do was add a single comment, and we get this feedback instantaneously. The next question is, why only 80%? And well, adding typed true to all these files revealed that we had a lot of bugs in our code. And we can only get so many of them fixed with such a small team. So as we were doing this across those 7 months, we built tools to help us fix the most common errors, which is how we were able to have such great success getting it all the way to 80%. So we're going to talk a little bit about the tools that we've built to automate the process of finding and fixing these errors a little bit later in the presentation. But it's more than just errors that we wanted to have Sorbet tell us about. Errors are so antagonistic. We'd like to be able to learn more things about our code as we're developing. We'd like to be able to ask questions about the code as we're developing. Questions like, what type does this method take? Or could this thing be nil? And so with Sorbet, we can do this. For example, take this code snippet. We've got a wonderfully named method, do thing, right here. Thank you to the previous author who wrote this code. It's a toy example on the slide, but who among us hasn't seen an absurdly named method before and just been left wondering what in the world is going on? So we're asking these questions like, is it okay to call this method with a string? Is it okay to call it with nil? Like, what's going to happen? And the only thing that we could really do at this point is dive into the code and hope that it's not too complicated and understand it all by ourselves. But with Sorbet, all that we have to do is add a single line to the top of this method that says, this is a method. It takes in an argument x that's a string, and it returns nothing. And now suddenly it's super easy to answer our questions. We know that it's OK to call do thing with a string, and it's not OK to call it with nil. So again, after the 7 months that we spent adopting Sorbet at Stripe, 62% of methods at Stripe have a signature on top of them that let us answer questions like what types things take, or how does this thing work? What does it mean to call this method? So to recap the numbers, 100% of files, we can now catch uninitialized constant errors. 80% of files, we can catch no method errors. And 62% of methods themselves have a signature on top to help us understand the code more deeply. But these numbers only tell part of the story. So we actually pulled some direct quotes from our users at Stripe, the engineers that are writing code, directly from our company Slack. And I'd like to share them with you. So the first one that we see here is from this person who says, I added strict typing to Opus ThriftGen because it's super helpful in understanding a package. I touch only once every never. Just wanted to say thanks so much. So more than just this tool that's coming in and yelling at you when you're doing something wrong, people are actually taking Sorbet and using it as a tool to understand code, to dive into something unfamiliar and add types as a way to explore new and unfamiliar code. Which is great because it means that after having done this, leaving the type annotations behind in the code means that people can now take advantage of this knowledge, of this understanding, any time that someone reads it after. Another cool thing that we saw someone say was, just wanted to say that the billing team loves Sorbet. Typed true is the best thing since sliced bread. I often feel like I'm pair programming effectively with the type checker. And so again, rather than it being some combated experience, Sorbet is actually something that people use as a tool, and it's almost interactive, that they're going and asking questions like, how do I use this method? Or what am I supposed to write here? Could I be doing this particular thing a little bit more simply? And so we really enjoy that people are taking advantage of and incorporating Sorbet into their workflow and iteratively updating things. And then so a little bit of context about this quote. About a couple months ago, well, I guess maybe almost 6 months ago at this point, we had a hackathon, and one of the members of our team decided that he was going to try to take Sorbet and integrate it into his favorite editor. And so what we see here is the result of when we shared it. So this person says, I would already pay significant money for this editor extension, loving it so much. And so the screenshot that he shares is, he went into the code, hovered over the name of a variable, and now you can see the type, which is just, again, something that's super fast feedback as you're developing code. And so we knew that after we did this hackathon project that we should probably commit to fleshing out this prototype and making something really great. And then the last thing that we learned from those 7 months of adopting Sorbet was one thing we were worried about was, is it going to be fast enough? And yes, it's actually really fast. Stripe, as Paul mentioned, has millions of lines of code. Sorbet type checks our entire code base in seconds, which is crazy. Of course, though, when we did this, people were like, seconds isn't fast enough. We need it even faster. They were asking for sub-second response times. They wanted their editor to respond to them as soon as they clicked the key. So we knew that we had to make Sorbet even faster. So at the end of these 7 months, to recap, we learned 3 main things. First is that Sorbet is powerful enough to model Ruby. It's not some toy that works on small examples like we saw in the slides here. It's actually something that works in the vast majority of Stripe's code base. The next thing is that while Sorbet is fast, people want it even faster to the point where they can use it directly in their editor. And then the third is that we only had a team of 3 people working on adopting Sorbet at Stripe, and it was still possible because of the automated tools that we built. So that's kind of what we're going to dive into for the rest of the presentation, is this editor tools that we've built and this automated tooling that we've built. So again, that's the recap of the last 7 months, and we're going to dive into editor tools and the open source tools that we've been building for the community. So the first one, editor tools. Here's a screenshot of VS Code as it appears at Stripe. What we can see is there's a little red squiggle where there's a typo. It says method charge ID does not exist. And so if we just add an E to fix the typo, the red squiggle goes away immediately, and we can now hover over methods or variables to see their types. And so this is something that we've actually built at Stripe, and this actually works. We built some more features into this. We wanted to make Sorbet more than errors, like we said before. We wanted it to be something interactive that you can ask questions. So maybe a question we want to ask is, where is this thing defined? And so what we see in this screenshot is we just right-click on a method and ask where it's defined, and Sorbet, or the editor really, jumps directly to where that method's defined. And the best part about this is not some heuristic-based thing. It's not using regular expressions to approximately figure out where this thing might be defined. This is using Sorbet's knowledge of an entire code base to know definitively where something is defined and to jump to it immediately. And then the next thing that we built into this editor extension is auto-completion and also documentation. So here we see someone typing out the beginning of a retrieve method, and as they do this, they see a list of auto-completion results. And again, this is not some heuristic about what potentially could be called here. It's not probabilistic. This is Sorbet knowing what type you're auto-completing on, knowing what methods that thing has, and then showing them to you. But it's more than just showing you the methods that are available. In the second pop-up that we see to the far right of the screen, it actually shows for the method that's selected its input and output types and the yard documentation from that method right above. So these are some really cool tools that we've built on top of Sorbet to make people be able to use Sorbet even better in their editor. So we'd actually like to invite you to try this out. We announced at last year RubyKaigi that we have this website, sorbet.run, where you can try things out. And because of the way that we've built Sorbet to be cross-platform, we can actually surface these editor features directly in the browser. And so if you visit sorbet.run on your desktop, you can even try these out, to try out auto-completion or try out jump to definition. And again, because we've built Sorbet to be cross-platform and work in a lot of different environments, we gave an initial kind of preview of Sorbet to our friends at SourceGraph, and they incorporated it into their product. So SourceGraph is a web-based code search and navigation tool for dev teams, and they basically build a Chrome extension that when you're navigating GitHub, you can see the same kinds of things that you'd see in your editor. And so what we see here is a GitHub repo with a Ruby project with a SourceGraph Chrome extension installed, and all you have to do is hover, and you can see the types of things directly in GitHub. And so after we open source Sorbet, more tools like this will follow. And if you think that you're building a tool that Sorbet could benefit, we'd love if you got in touch with us. And we'd love to work with you to make better tools on top of Sorbet. So that's pretty much it for the editor tools that we've been building. And now I'd like to hand it off to Paul, who's got a couple exciting announcements for us.
Thank you, Jake. OK, I have 4 things to tell you today. Number 1, as you probably heard yesterday at Matt's keynote, Ruby 3 and types are now friends. So we've been working very closely with the core team on this, and we really appreciate all the collaboration they've been doing. Hopefully you've already watched the talks by Mats and Mame-san. Go see the one by Satoru tomorrow about Steep. But type definitions for the standard library will be coming, and we will happily use them from Sorbet when they appear. Number 2, Sorbet is open sourcing imminently. We already are in private beta. We have 3 core companies that are already coding with us. We've sent it to 5 other companies for testing, so just as black box people, not with source code. And if you would like to be among this class of people, please send us an email, sorbet@stripe.com. Send us your lines of code, what size of company you are. It's interesting for us to know what context you were going to be using Sorbet in so that we can get a good approximation of what the open source community will use. I have to say, I have to get ahead of this. Why is it not open source yet? Well, our philosophy on open sourcing is that we would like to ship a polished, amazing product. We want it to work out of the box. We want you to download it and be amazed the first time you try it. So we want to slowly expand our private beta. We want to try it over small companies, huge companies, medium-sized, open source projects, the whole gamut of people that would use Sorbet as a type checking tool. And we want to make sure that our tool chains just function straight out of the box. So once the experience is good for a good set of people, we will happily open the floodgates and let everyone else try it out. But we want the experience to not be rocky right out of the beginning. Of the people we have been trying, I've been very happy that most of the problems are fit and finish. They are, why isn't there an error message printed here? Or could you please tell me what the next step is for me to do? Those kind of things. Not like, this is seg faulting on my code base. So I'm very happy that the shape of things is imminent. We have a date. This summer, if you can call that a date, is when we're going to be releasing Sorbet. Watch the Stripe blog. That's where we're going to post our announcement and hopefully Hacker News too. Number 3, the docs are live. Okay, so you are welcome to go to sorbet.org and not listen to the rest of my presentation and go and peruse the docs. So these are, Jake has been wildly typing for the last 2 months to create these pages. And if you have any questions about anything there, please email us, sorbet@stripe.com. If you have any feedback about how we're deploying it or how we're thinking about our type system, we would just love to hear you. This is a very strong sneak peek about how Sorbet is going to work. It's announcement number 3. Number 4, I want to dive into how our open source tooling is going to work on all of your code there. Okay? So basically, you're going to have 2 gems. Sorbet for development, the things that run on your laptops before it goes into production, and Sorbet runtime, which is like a contract thing that you've been seeing these SIGs everywhere, so that you can annotate your type signatures for runtime use. The first time you start your project, you run srb init, and it writes out a bunch of stuff, gets your project all ready for Sorbet to work on it, and then you run srb, and hopefully it says no errors, good job. If this happens, then you can go forward and put Sorbet into any files and start upgrading your typedness of your code. All right, those are 4 announcements. I love doing those parts of the presentation. OK, I want to dive into some of the tooling choices that we have for open sourcing, and hopefully I can get some of your feedback if any of this is astonishingly bad or astonishingly good. All right, so when you run srb init, what does it do? It writes out a Sorbet directory into your file system that is meant to be committed to your source control. Inside this is a config file, a very simple file for config options to be passed to Sorbet by default, just so you can run srb and not have to pass any defaults. Straightforward. And then it generates 4 tiers of files. The first tier, Sorbet typed. If any of you are familiar with definitely typed from JavaScript, where we put together a community-run repository of annotations for gems for their type signatures if the gem authors haven't included the type signatures already. So there's already a repo there, and we just we look through your gem file and download all of the type definitions for any gem that you're using so that Sorbet can see the types for the methods in the gem. That's the first tier. Second tier. Anything that doesn't have a community annotated type definition, we load up your gem in memory and then walk object space and see what constants did this gem make, what methods are on those constants. And then we serialize those back out into the gems directory so that Sorbet can see the methods that were generated by the gems. They won't have types on them, right? We don't know what, but they will have arity. Right? We'll know that it takes 3 parameters, or it takes a keyword arg, or something like that. Right? So it will have a little bit of information for the static type checker to use, and we want to serialize that back out so that we can catch things like missing constants and whatever. All right, that's 2 tiers. So far, it's not too horrible. Now, hidden definitions is our way of dealing with metaprogramming. Okay? So if there's a method in your code that just like you create a DSL and it generates methods out of thin air, we can't see those statically. We don't know that they exist at sorbet time. So what we do is we require your entire project into memory. We walk every file and just require it. And then we look in object space and say what methods exist. And any methods that do exist, we serialize them back down and then compare. What does sorbet see in your source code, and what do we see at runtime? And everything that's hidden, everything that's extra above and beyond that sorbet didn't see, we write out into this directory. So this is our third line of defense to help deal with metaprogramming. And all of your magical methods, all of the things that you can't see statically end up in this directory. And then lastly, if we didn't catch anything, we make you a to-do file of all of the constants that just like, we don't know where they came from. But in order to resolve your constants in your code base, we print these out. So these are our 4 lines of defenses. This is what SRB init will print out. And after this, your code should be type checkable. As I talked about, the sorbet typed repository is live. You can get it at github.com/sorbet/sorbet-typed. Please send us type annotations to your favorite gems if you'd like. The tooling should pick it up automatically. You can also include the RBI definitions directly in your gems too, and our tooling will pick it up. You can see that in the docs. OK, there's been lots of discussion. How do you deal with DSLs? So I talked about the hidden methods in detail. That is a fallback. It's much better if the type checker actually understands some of the more common DSLs. Rails, for example, has this inactive record. It has an attribute DSL where you give it a property and a type. And these 3 methods get generated for you automatically by Rails. Right? So just by writing attribute myId integer, you get a myId method, a myId question mark method, and a myId equals method. A getter, a checker, and a setter. Right? So how can sorbet understand this kind of thing? Well, we have a plugin system built by our friends at Shopify. Thank you very much for doing that, folks. Where you pass a plugin.yaml file, specify which DSLs you're working on. You're working on the attribute DSL here. And then you give it a Ruby file. And that Ruby file is a preprocessor that converts your DSLs into the methods that they will generate at runtime. So in this instance, we take standard in, do some awful parsing on it. Please do it in a more production-friendly way when you really write your DSL stuff. And then prints out the defs and the sigs and the like statically analyzable parts of your DSL. And then sorbet just sees the bottom thing. It doesn't see attribute myId integer. It sees the def method. And because of this, we can actually understand at a deep level DSLs in your code base. And we don't have to do the hidden methods. It just works out of the box for any of the common things that have already had these plugins written. So hopefully that will help out adoption from our DSL friends. All right, how does it work in practice? Well, earlier, maybe a couple weeks ago, I downloaded the Rails blog default app. This is when you're going to learn Rails, I don't actually know Rails, so I went to the website and went to their tutorial, and it told me to type this command. So I typed that command, and I made a great blog article where I can post sorbet is awesome to my own website. I did that. Turns out it made 122 files for me, of which 120 were type checkable. Only 2 files were painful enough for sorbet to not understand the method calls inside them. One of them, config.rb, changes its scope at the root level so that a bunch of methods, a bunch of DSLs are in a different scope than the root namespace. And I don't remember what the other one was. Some test something. But most of the files in the default Rails project actually type checked. Very cool. But what about bigger code? Well, rubygems.org, the website that hosts all of our gems, all of our lovely things that power all of our stuff. If you download their source code, run SRB init on it, and then check what typedness is, 58% of the files out of the box are type checkable by sorbet without having to doing anything. If you start working on this, you can drive those numbers up, no problem. And lastly, what about something big? Well, the biggest project we knew open source was GitLab. It is almost 10,000 file code base, all written in Ruby. And it turns out 99% of the files were we could resolve constants in, as Jake pointed out, the constant resolution thing, making sure that you don't misspell your classes. And 19%, just straight out of the box, we understood the type checkability of them. So they use the standard library a lot. This is a lot of standard library stuff. So it was very exciting for us to be able to take these large projects and actually have Sorbet function on them without any modifications to the original source code. What did it take to type check Rails? Took 7 handwritten type signatures. You'll see them all in this Sorbet typed repository that I had to write earlier. And it took 1 new feature, bind. Rails really likes to take a block and change the scope of what that block is going to execute in. And statically, we didn't support this kind of thing. So now we have an annotation where you can say what context a block is going to actually execute in. So now that we have the bind keyword, we can type all of these Railsy things. All the other signatures were just auto-generated, just the basic Sorbet init stuff. All right, in closing. Number 1, editors are a big, important thing for us that we've been working on recently, and we're going to plow on editors very hard. We think that's where the future is for static type checking. 2, open sourcing is very soon. If you would like in the private beta, please email us, sorbet@stripe.com. We're already working with a bunch of people. We would love to work with you too. It does work with Rails and metaprogramming. We tested it. It was a big unknown for us whether this was actually going to function. And this is the big announcement that at this RubyKaigi that yes, metaprogramming is workable, and yes, Rails is workable. And lastly, as everyone I've seen is staring at their laptops, hopefully perusing our documentation, sorbet.org is live, and you can go check out the Sorbet docs. All right. Thank you very much. Arigato gozaimasu. I think we have time for some questions if folks would like to approach the microphones. Please, English if possible. Yep. No rush.
So it's great that you do type level checking against arguments, constants, and return types, but one could construct an argument that says exceptions that a method returns are also part of the type signature of a method. Those require us a certain degree of more dynamic analysis. Have you done any work on checked exceptions or similar with Sorbet?
So
great question.
That's a great question. Thank you. So the third person of our team, who unfortunately could not make it, Dimitri, I mentioned you, he was the guy who did the hackathon prototype of the editor. His previous experience was working on the Scala 3 compiler, like writing the Scala 3 compiler. He's got a lot of experience with JVM, Java sorts of things, and I get lunch with him a lot. And one of the things he likes to rant about is how bad Java checked exceptions are. So
sure.
I think that he's tried to stay away from them as much as possible, and luckily we've found tons of value with just the way that Sorbet is now. And our kind of philosophy is let's make Sorbet powerful enough, but not overly complicated. And so we could potentially see doing something like this in the future. It just hasn't been something that we needed just yet.
Okay.
The number 1 class of constant errors was actually misspelling the error you were catching. So people would not know how to spell JSON exception or whatever. They'd get the capitalization wrong. And because there's no tests for the error cases, that was our number 1 problem that we found when checking constant errors.
Great talk. I'm super excited to start using it. I'm particularly excited for like the DSL support because that's something that tends to be lacking, I think. One question I had is are those plugins like namespaced kind of? Like 2 different libraries could have the same DSL method. Is there support for that?
Great question. Our plugins actually run before we resolve, so they are only top-level name-based right now. Okay. So if 2 things have the word attribute, you have to only run one of the plugins on your code base, and good luck. If you have ideas of how to expand this kind of thing, we would happily take any patches and any ideas in this space, but right now they run before the resolver, so we don't actually know what to resolve to.
All right, thank you.
Yep, thanks. It is very nascent, our plugin system, so ideas and patches welcome.
Are there any sort of affordances for duck typing with a sort of approach?
Great question. So the number one thing that a type checker gives you is error messages. The job of a type checker is to tell you what the problem is. And with duck typing, the error messages get very long and very hard to know which of the methods you didn't expose correctly from your duck type. We've found that a nominative type system where you actually have to name your interfaces provides much better error messages than if you did just a descriptive type of style. So there's nothing forcefully in Sorbet that does not allow duck typing. Just we've chosen to make the programmer write a name for all of their interfaces so that we can anchor to that name in the error messages. So for example, if you want something stringable, you make a module called stringable that has one method, to_s. And now everything can talk about stringable, rather than missing this one method. So we could support it in the future, but we've chosen to do a nominative system for now.
Cool. I think I would prefer that way, actually. So.
All right, man after my own taste.
Hey, really excited to see the Sorbet coming. For the editor tooling, are you guys planning or already using language server protocol?
We are, yeah. That was all powered by a language server protocol. The cool thing is that VS Code is written in JavaScript, and their core editor is actually an npm package. And so if you go to sorbet.run, we're actually using VS Code's language server client in the browser. So it's all powered by LSP, and it works like with Vim, with Emacs, like whatever language server client you're using.
Thanks.
Open your JavaScript console. You'll see the LSP messages. I should probably get rid of those.
Hi. Great talk. Really advertised Sorbet very well. I was wondering, so a lot of Ruby testing is due to the fact that Ruby's not typed. And since implementing Sorbet has the way that you test your code change, and how does it impact the testing culture at Stripe?
Great question. Has adopting Sorbet influenced our testing culture? Absolutely. We used to have an enormous amount of tests that would just pass the wrong types into a method to make sure that the method errored correctly. And those tests have just evaporated. You no longer have to bother with your typedness tests. And instead, you try to test at a semantic level, much more than a syntactic typedness, because you know that the runtime is going to catch you, and you know that Sorbet is going to catch you on your type errors. I don't think it also has much more reduced the polymorphism of our internal methods. Like when you have to write your type signature that this thing takes a string and a symbol and an array of strings and you start actually writing out what this thing takes, you think twice about what your method should actually take, and you might split it into a couple more methods. So it does affect the way you end up coding at the end if you have it typed in your brain as you're going along.
I think we have time for one more question.
So how do you deal with variadic arguments like star args, star quads, optional in both positions?
Yep. How do you deal with, the question was, how do you deal with variadics? So we found that our variadic support is the simplest part of the type system that we could do that was still useful. So what we do is if you do have a star args, you get to pick one type for all your star args. You could pick object. That's cool. But you can also pick integer and all your args. And it turns out most of the code turns out to be not polymorphic across the var args. Same with quargs, all of these things, you annotate one type for the entire thing. This is up to debate if you'd like. We can change it, but this is our current implementation.
Yeah. It's kind of similar to how Scala does it, where the rest args all have to be the same. But if you explicitly, if you have quargs, and then you explicitly name those args, then you can have them all be different types. It kind of works the way you expect.
Try it out on sorbet.run. OK, we will be here for the rest of the conference. Please come find Jake and myself, and thank you very much for your time.